Okay, so we have here a circuit, and we are asked to determine the value of I1, I2, and Vx using the basic laws of circuit analysis. And when we say the basic law, so it refers to the Ohm's law, voltage and current divider, as well as the Kirchhoff's law. Okay, now let's find the value of I1. So as you can see, that's the current that flows through this branch. And we have here the current source, and it flows in this branch entering this node. So after entering this node, it will be separated through this current that flows through the R1 and the I1. So we can actually use current divider to solve for I1, but of course before that we have to find the equivalent resistance on this part. Okay, to start, let us first get the series combination of R4 and R6. So that would be R4 6, R4 plus R6, and that would be 20 plus 40 equal to 60 ohm. Then this R46 will be in parallel with R3. So R3 6, that is R3 in parallel with R46. And we know that if two branches or if two resistors are in parallel, so that would only be 240 times 60 over 240 plus 60, or that's R3, R46 all over R3 plus R46, and that is equal to 48 ohm. Okay, and after simplifying that, it will be in parallel with this resistor, the R5. So let's say that is R56. R56 is equal to R5 plus R36. R5 is equal to 2 plus 48, and that's equal to 50 ohm. Now we have here R2 and the R56, which is in parallel with each other. So let's say that's R2 6. R2 is in parallel with R56, and that is both 50. So actually, if two resistors are in parallel and they are the same value, so it's like dividing them into two. So we have 25 ohms. Now, if we will try to redraw this one, so we have here 120 milliampere. Okay, and this is the R26, the 25 ohm, and we have here the R1, and this is the I1, the one that we are looking for, I1. So how to find the I1 using current divider? Okay, so for I1, that is I1 is equal to 120 milliampere multiplied by the other branch, so that is R1 over R1 plus R26, and that's equal to 120 milliampere multiplied by our R1 is 125 over 125 plus 25. So our answer would be, let's check, 125 over 125 plus 25. Ayan. So our I1 is equal to 100 milliampere. Then, now that we have the I1, we can solve for I2. Okay, so this I1 is entering this node, okay, this node, and it will be separated with the current flowing through the R2 and of course the I2. So we can actually use the current divider again. So to solve for I2, so using current divider again, I2 is equal to the current that they will be using, that is the I1, okay, I1 multiplied by this resistor, the 50 ohm, or let's just say that's R2 over R2 plus this part, so this is R2 R56, no, that's R56 combination. So we have I1 as 100 milliampere. Our R2 is 50, then divided by 50 plus R56 is 50. Okay, so our I2 is equal to 50 milliampere. Yes, we have 50 milliampere as the value of I2. Now to find the Vx, okay, so to find the Vx here, we have to get the current that's flowing through this resistor. And to do that, we have I2. And if the I2 enters this node, so it will be divided into the current that's flowing through the R3 and the current that's flowing through this branch. So to find the current, let's say that is Ix. So Ix is equal to I2 multiplied by this branch, the R46. R46 over R46 plus R3. And that would be 50 milliampere multiplied by our R46 equal to 60 all over 60 plus our R3 is 240. So that would be 10 milliampere. Okay, and our Vx is equal to Ix times 240. So Ix is 10 milliampere multiplied by 240 ohms. So that's just Ohm's law. So 10 milliampere multiplied by 240, and that is equal to 2.4 volts. And that is our answer. Now, if you want to get, for example, the voltage drop in this R4, for example, we have here, say that is Vy. Okay, so if I want to find this one, we'll just have to find the current that flows to the branch. And since we have already solved the Ix is the current that flowing through here, we can just subtract Ix from I2 and we'll get the current here. So let's say that is Iy. So Iy is equal to I2 minus Ix. And that is equal to I2 natin is 50 minus Ix is 10. So Iy is equal to 40 milliampere. And our Vy is equal to Iy times 20 ohms, and that is equal to 40 milliamps multiplied by 20, and that is equal to 0.8 volts. Ayan. Okay, so we have here a circuit and we are asked to determine the value of Ix, Vx, Iy, and Vy. Okay, so we can actually find the Ix. Okay, so by inspecting this circuit, you can see that R7 is just in parallel with the voltage source, as well as this branch. No, this branch is in parallel directly with the voltage source. That's why our voltage drop here is equal to 24 volts. And to find the Ix, you can just use Ohm's law. That's V1 over 100 ohm. So V1 is 24 volts divided by 100 ohm, and that's equal to 240 milliampere. Okay, now to find the Vx, okay, so this Vx here, So to find the Vx, we can just use voltage divider since parallel, this whole branch here, the R8, R9, and R10 is the total voltage here is 24 volts. So Vx is equal to 24 multiplied by 100 divided by 100 plus the parallel combination of R9 and R10. Since it is of the same value, and as I've said earlier, if we have two parallel resistors with the same value, it's like dividing them into two. So this one is actually equal to 25 ohm. So this is 25. And 24 times 100 over 100 plus 25, that is equal to 19.2 volts. Okay. Then next, to solve for IY, okay, so to solve for IY, so we have to get the equivalent resistance of this part. Okay, so this part, yan. Since this part would be in parallel with the voltage source, so the voltage drop on this part is equal to 24 volts. So if we will get the total or equivalent resistance for this part, we can get the current flowing through this branch. Okay, and that is our aim. So let's simplify. So 50 and 50 here, that's also 25. Then this one is in series with each other, this branch. Okay, so let's say that is our RL na lang. So R last. So R16 plus R12 plus 25. So that is equal to 40 plus 200 plus 25, and that's equal to 265 ohms. Okay, and this RL is in parallel with R11. So let's say that's RL11, and that is R L in parallel with R11, and RL is equal to 265 times 200 over 265 plus 200, and that is equal to 265 plus 200, that's 10,600 over 93. Let's store this in A. Okay, then after that, let us series it in R15. So let's say that is RL15. That is R15 plus RL11. So R15 is 40. So 40 plus 10,600 over 93. And that is equal to 14,320 over 93. You can just store it in letter B. Okay. Ayan. So now that we have the RL15, we can solve for the current flowing through this whole branch. So let's say that is IL15. IL15 is equal to 24 volts divided by the B. Say that is letter B. Okay po. So 24 divided by B, that is equal to 0.15 or 279. In fraction, that is equal to 279 over 1,790. Okay. We can start it in C if you want. Yan. Then, to solve for IY, so we have here the current. It will be divided into the current that flows through the IY and the current that flows through this last branch. So, to find the IY, so just current divider, IY is equal to C, this one, so IL15, multiplied by the other branch, so this branch is the RL, okay, over RL plus R11. So our C is 279 over 1790 multiplied by our RL is 265 over 265 plus our R11 is 200. So that would be 8 88.8 milliampere. So IY is equal to 88.83 milliampere. Now, to solve for VY, so we just only have to get the what do you call this, current that's flowing through here. So let's say that is IY prime. IY prime is equal to IL 15 minus IY. So that is C minus the answer that we get, that's 88.83 milliampere. Okay, so that is C minus our answer, that is 12 over 179, okay, ampere. And to solve for Vy, finally, that's just IR, or that's IY prime multiplied by 200. So that's 12 over 179 times 200, and that is equal to 13.41 volts. Yan. Now, if you want to check your computation using multi-sim, so you just have to construct the circuit and use multi-sim. So to measure the current, you just have to series the multimeter and the component you want to measure. Then for the voltage drop, just connect your multimeter in parallel with the resistor that you want to measure. And then just click A for current and V for voltage, and that's it. And of course, don't forget to click the simulate run in this tab, the simulation toolbar. Okay, and the measurement will be displayed, and it matches the computation we got earlier. Okay, so that's it.